Time. My name is Mauricio Cruz. I'm a director of product management responsible for Core and Edge. I'm joined today by Iqbal Sayed and Amar Khan, senior product managers in the Cisco 8000 product management team. First, let me start by talk about our investment strategy and how it's evolved over the last couple of years since the last time we were here. On the Cisco 8000, we're basically focused on four segments. Initially, we started with our web and cloud customers, right? We have a series of foundational technologies, many of which have been described by our colleagues earlier today, right? Jose, GD, Rana, and a few others. So we're trying to make strategic investments in these initial four pillars of our strategy. Some unique things that we hear from our customers, right? Web and cloud, a lot of asks on telemetry, open config, IP and IP, etc. We have a diverse portfolio. If you remember what we talked about 2 years ago, we're building modular systems as well as fixed systems. So we have three parts of our portfolio that we will cover next for web and cloud. We've also been working with our service provider customers, mostly targeting them with our modular portfolio. We're leveraging a lot of innovation on SRv6, just as explained by Jose, transport and services, SRTE. Over the past few software releases, we've continuously added capabilities on top of our hardware. Peering, right? There's so many features that it's just the few ones that we called out here don't make justice, but definitely a lot of focus on things like QPPB, BGP FlowSpec, RPKI, to also bring this innovative product family to these type of use cases. And we're also starting our journey on service provider aggregation. I think everyone acknowledges that over the next 5 to 10 years, there's going to be a huge transformation in how service providers build networks. So we're also making investments, both in hardware and software, for this part of the network. I want to give you a quick snapshot of our success so far. So firstly, in all of these use cases that we set to invest, we have had marquee customer wins. In web and cloud, some of you may have seen the press releases or the announcements of our strong collaboration with the likes of Microsoft, Facebook, and others that we're working with but are not public references yet. In the core segment, we've worked very closely with the likes of DT, Telia Carrier, not only for the benefits they see from this innovative platform and its benefits in terms of space saving, power savings, but also the integration of routed optical networking technology. Some examples here, WebSpring, Cold, Packet Fabric, Telia Carrier, and many more that are not public references. Peering as well, right? We're working with Facebook on their content delivery network with the potential to take this platform to hundreds of customers worldwide. And aggregation, right? We're starting to increase our software offering on aggregation, so we're starting to collect logos in there. So more than 50 plus customers that have chosen the Cisco 8000 for their evolution. We're rapidly growing the number of systems that we have shipped to these customers. As you can see here, more than 12,000 shipped systems, and our pace is growing quarter over quarter. And from a type of technology perspective, we're seeing a very healthy mix of 100 gig based networking and 400 gig based networking from our customers. So I think the way we've chosen to present the product to our customers is having good traction. What is the cornerstone or the core building block of the Cisco 8000? It's Cisco Silicon One. Cisco Silicon One comes as a single architecture, single forwarding architecture based on slices. It has a common SDK, so that allows us to be more efficient in our software development, and common P4 forwarding code. The Cisco Silicon One, when we last spoke in this forum 2 years ago, we were just releasing the first generation, what we call the Q100. In the 2 years since, we've been quite busy. We're now in the third generation of Silicon. Over the last 2 years, we spoke about the Q200 series, which is a second generation of the Cisco Silicon One. And then very recently we spoke about the G100 and the P100. The lineage of the Cisco Silicon One can basically be divided into two main use cases. Web scale switching, right? From basically this means shallow buffers, right? From 3.2T all the way to 25.6T. You will see different instantiations, how we've taken these different sizes of the silicon to create products specific to these use cases, the Tor, leaf and spine in the web scale providers. That's what we call the Cisco 81000 series. And on the routing aspect, so we take the same principles, but we co-package high bandwidth memory to perform advanced functions, obviously buffering, but also ACL, statistics, etc. in the HBM. On this one, right, it's packaged both as modular systems with line cards as well as fixed systems in the 8200. So this silicon allows us to address use cases ranging from DCI, core, peering, SP aggregation, etc. So you will see that we have created a variety of products to benefit from the Cisco Silicon One.
I see P4 is mentioned in there. Is that anything that's exposed to the customer, that if they're doing their own P4 programming, or is that something that's internal to Cisco?
For the vast majority of our customers, this is internal. For certain customers where, Cisco has become very flexible in how expose this technology to our customers, right? Some of our customers will consume this as integrated systems, so they will not be exposed to the P4. Some customers will choose to implement their own OS on top of existing hardware. For them, they will go through the SIA, software abstraction interface, and some customers will take the silicon themselves and then work on top of that. So for those few customers that have that software capability and that experience, they can do prototypes and they can do certain things through the P4 code.
Hi everyone, my name is Amar. I am 8000 group under Mauricio, covering 8,000 platforms. So this slide is an overview of the modular system portfolio that we have. These are all components or devices that are in production, and we're going to go through each of these sections. We'll parse through the slide, but before I do, I just wanted to talk a little bit about these 4 points that we have mentioned here: the clean slate, versatility, and options and rapid portfolio adoption. So this is a clean slate design. There's a complete paradigm shift. So the new paradigm requires new way of thinking, and this is exactly what we did with Cisco 8000. Everything that we had done in the past, coming out with world-class systems that are currently deployed, we had to look at all of those assumptions again. And starting with silicon, so there's plenty of innovation that has gone into silicon. Mauricio talked about silicon innovation, specifically, how silicon is designed. For the first time, you have a silicon that is multi-terabit silicon, yet it is programmable. So there is no feature compromise. There is this demarcation line between switching and routing that is sort of blurring, because now you have multi-terabit silicon, 10.8 terabit, 12.8 terabit, just recently announced 25.8 terabit, and they are P4 programmable, single SDK, all silicon can be used. And then the architecture itself is so flexible and scalable that you can easily scale the architecture without having to worry about all the ASIC challenges that you will see when you scale ASICs up. It's very easy to do, and the fact that we have such a rich portfolio of ASICs in such a short period of time is an attestation to this architecture elegance and how elegant this architecture is. So we do have a lot of innovation that has gone into Silicon One. If you crack open Silicon One, the advanced memory architecture with which we handle forwarding tables and buffering based on-chip resources, off-chip resources, that's industry leading, and it is very innovative. Similarly, there are a lot of other things that we have done inside the silicon that are and with the silicon that are just industry first in some ways. But this is not where the innovation stops, right? We have to come up with more innovation or more innovative ideas at the system level, because after all, we do produce systems. So a lot of innovation has gone into the system design and development as well. especially when you are transitioning from 50 gig SerDes to 100 gig SerDes or 25 gig SerDes to 100 gig SerDes. All those wonderful things that we have learned in college and we have used in the past, I've used in the past as a board designer and as an ASIC designer, they're all much more pronounced. Signal integrity, parasitics, ground bounds, crosstalk, all of these things, and how you do power distribution, high-speed logic, all the component selections that you make, and all the thermals, and how do you handle thermals and everything else. Everything is much more pronounced, and you have to handle it very differently. And that's exactly what we have done with 8000. So 8000 is a clean slate design with a brand new paradigm, and that's it. That's how we are able to achieve what we were able to achieve. But one very important innovation that I forgot to mention is about the silicon, is the silicon architecture ability to be able to use in multiple different roles with ease, with seamlessly. So you can take the silicon, configure it, and it is all I/O, and it can be used as a standalone silicon, or what we call router on a chip. You can take the same silicon, you can program or configure some of its I/O to be front panel facing, and then you can take some of this I/O for fabric connectivity. And you can use the same silicon to configure all the I/O to be fabric processing I/O. So all this silicon will do is it will process packets with internal headers, and this is exactly how chassis are put together. So this level of integration is so important and critical, and I think it's such a customer-centric approach, because now you just have to do one silicon, one architecture, one SDK, P4 programmable, with which you can put a system together. You don't have to worry about a separate architecture for fabric ASIC. You don't have to worry about legacy architecture that you're using for line card development, and then you have to put it all together to come up with fixed boxes. That's the approach that we are not taking. So this is all very important and critical to us, and that enables something very special and important. That's the versatility part. Mauricio mentioned that these platforms are used in many different roles, and these multitude of roles that we have enabled with 8000 is only because of the fact that we have a silicon where you don't have to make any trade-offs. I need a little more capacity, then maybe I give up on some features. None of that is happening. So you have feature velocity, plus you have a scale. And this way, these boxes, fixed as well as modular boxes, are deployed in multiple different places. They are used in data center leaf spine topology. They're used as DC core, DC fabric, data center interconnect. They're used in large SPs, core routers, backbone routers, peering routers. They're deployed worldwide. All these boxes, obviously there are some referenceable accounts. All these boxes are switching live traffic. So we are in a we are poised for growth, and we are in a much better position. And then the other thing, which is also very important to us, is the operational aspect of it. We want to make sure that our customers who are challenged with OpEx and operational challenges, we address those. We have a very rich portfolio, which is growing. And this portfolio has multiple options for customers. You can use, we offer customers dense 400 gig line cards, dense 100 gig line cards with MACsec, without MACsec. We offer customers transitionary line card where they can they're in the process of doing their 100 to 400 gig transition. We have fabric cards based on Q100 and Q200 silicon. Mauricio touched upon that. Q100 silicon is in 16 nanometer process, and then Q200 silicon is in 7 nanometer process. There is so much to gain from moving from one process to another. So process transition helps us with better power numbers, so you can have power benefit. But at the same time, the most important piece, again, operationally, is that they're all forward and backward compatible. So you can use Q100 line cards with Q200 line fabric cards. You can use Q200 line cards with Q100 fabric card. All chassis can have all these line cards interoperate within a chassis. If you look at the chassis, the line cards are horizontally oriented, and the fabric cards are vertically oriented. So they connect orthogonally. There is no backplane. The connectors with which the line cards and fabric cards connect are future-proof. Every component that we have designed into these chassis is future-proof. We know that today we are at 400 gig. Soon we will transition over to 800 gig when 800 gig is available. But of course, we are going to increase the density of 400 gig and move to 800 gig. And then whatever comes next, 1.2 terabit, 1.6 terabit, whatever the next interface is going to be. These platforms are designed to handle that transition. And when you transition from SerDes to SerDes with different speed, all the things that we discussed, they're much more pronounced. So we have already figured out how to design the platform in such a way that we accommodate these changes, both from thermal perspective, also from pure performance perspective. Performance is important. You want to extract maximum performance out of your SerDes, because that translates into, again, operational aspects, which is that you can enable fabric redundancy, you can enable performance of your front panel. So you can get 14.4 terabit, which is the slot capacity of these chassis.
Looking at this portfolio, are there any plans for perhaps a bit of a smaller modular option? Some other vendors who will be unnamed have like a nice 2-line card option that has a nice, redundant control plane and then 2 line cards, and that really fits a pretty nice niche in my opinion. And I think it'd be interesting to see if there's plans for that. And then second question would be, is there plans to support lower speed line cards for legacy customers and stuff like that, or is the idea you would hang off switches and stuff for like 10 gig customers or something like that?
Absolutely. So first, to answer your first question, yes. I mean, it all depends on market reception and what market is looking for. Definitely, it can be done. We can come up with a lower form factor line chassis. It all depends what customers are looking for, what the requirements are. We'll have to do some investigation. We can certainly do that. The second part is that these platforms are optimized for 400 gig. Obviously, there is some inefficiency if you go below that, and of course, you can 100 gig will be fine. But all the 400 gig ports and 100 gig ports can be broken into 4x10, 4x25, and 40 gig. So you certainly can do that. But if you want to have lower speed, there are other silicon members that we have in our portfolio that will support lower speeds. We certainly can do that. That again is that again ties into the architectural benefit of Silicon One. The fact that you are able to, using Lego block approach, put in max, because that's what it translates into. How many max can you have? 100 gig max, 10 gig max, 40 gig max, 25 gig max that you can use. So you can easily do that. And we do have in our portfolio, which Mauricio presented, we do have silicon where you can do lower speed. If you want to do high density, low speed systems, yes, this can be done. Yes.
Chris, let me just expand a little bit more on that one. I think this speaks for the interest of using the Cisco 8000, not only for the very large, very high dense applications, but also for some other use cases where 400 gig and 800 gig interfaces are not going to be required for a period of time. What I can tell you is, yes, we're definitely working on some of these concepts. And just right now, the guideline is to focus on the things that are imminent, and that's what we're going to cover today.
We are seeing very good market reception. We have shipped thousands of these platforms already. A4-slot is the newest member of our family, and already we're getting a lot of good traction with customers for 4-slot, and things are looking pretty good. This is a portfolio that is currently in production. So this is just our 48 by 100 gig Q100 base platform line card. The reason I put this line card in here is because we have shipped thousands of these line cards already. They are deployed in many different roles: core, peering, leaf spine. But to me, this line card is a key enabler. This is enabler because it's a high density 100 gig line card. That is our first step in our transition for our customers to 400 gig. So customers are using this line card right now, enabling 100 gig and connecting to 100 gig infrastructure using a platform that is optimized for 400 gig and beyond. So the transition will happen, and this is the line card with which our customers will enable that. All ports support 100 gig MACsec, and every line card supports Class C timing. This is this slide covers 2 line cards that we currently have in production. These are Q200 base line cards. These are our high density 400 gig line card. The difference is one line card has MACsec, the other one doesn't. So we give our customers options. Where customers need to use MACsec, they certainly can use the MACsec line card. And where they don't need MACsec, they can use the 36FH line card. And we do have customers who deploy both these line cards in their network. So they're being judicious in terms of power dissipation and how much power it's going to consume. Regardless of MACsec, whether it is integrated in the chip or it is off chip, it's going to dissipate the same amount of power. So there is no change there. As far as breakout is concerned, all the 400 gig ports break out into 2 by 100, 4 by 100, but these 4 by 100 breakouts are single lambda breakouts, which is QSFP28. And then you have 4 by 25 and 4 by 10. And 100 gig ports, which is all the you can break them out into 4 by 10 or 4 by 25. In this particular case, this is an error. There is no 100 gig port. It only has 400 gig ports. Well, let me move on to the next slide. This is a newest member of our portfolio, and this is a combination line card. It has 34 ports of 100 gig, QSFP28, and it has 14 ports of 400 gig. It supports a MACsec on 16 ports of 100 gig, so it has 100 gig MACsec on it. And here, the 100 gig ports break out into 4 by 10 and 4 by 25, and 400 gig ports do the standard breakout of 2 by 100, 4 by 100, and 4 by 10, 4 by 25. The 400 gig ports, in the previous line card, the MACsec and both line cards support ZR and ZR plus. Here, in this case, we have 14 ports of 400 gig, and these 14 ports of 400 gig support ZR and ZR plus. Specifically, ZR is supported already. We are working on the ZR plus part, but it'll be supported as well. Like I said, all the line cards support timing, Class C timing, and MACsec is supported in 16 ports.
If you could maybe go into a little bit more detail around the port configuration, specifically, I see you listed out 34 by 100 or 14 by 400. What about when you mix 100 and 400 together? Especially when you have to consider buffering and stuff, that can get pretty complex quick. So I'm kind of curious, what are your options when you're mixing and matching speeds?
Yeah, so when you mix and match speed, the buffering requirements do not change. Like I mentioned, we have a standard, I think it's 8 millisecond of buffering or 6 millisecond of buffering, but you certainly have resources on chip, like Mauricio mentioned, HBM, which is stack memory that sits on the in package. And so you can easily transition and increase the buffer by judiciously moving your VOQs into HBM and then pull them out or evict them when they are not needed. So there is a lot of elasticity that is built into this silicon, with which you can easily maneuver the increase in your VOQs. And of course, you have your thresholds, which I think are user programmable. So you can put your thresholds in, and if your VOQs are growing, you can do packet drops. So there's quite a bit of flexibility in terms of VOQ or buffer management.
Yeah, Chris, if I may expand a little bit, right? The way this line card has been designed from a hardware routing perspective, the mix of 100 gig and 400 gig ports has been balanced, right? So it's not like we have, all of the 100 gig ports to one NPU and all of the 400 to the one is well balanced. So there are no restrictions in terms of mixing 34 and 34 by 114 by 400, right? It's balanced, from the NPU perspective, and it's also balanced in terms of the slices, right? If you may remember the slice architecture of the Silicon One. So we've taken care of that.
So hello, everyone. My name is Iqbal Syed, and I'm a Cisco 8000 series product manager. I also work for Mauricio, and today I'll be covering the Cisco 8000 fixed portfolio. So let me start with my first slide here. As Mauricio and Amar both have talked about, we have, from the Silicon One perspective, we have sort of two variants of the Silicon One. One is with the HBM and one is without the HBM, right? So, and if you recall Mauricio's slide earlier, the Cisco 8200 series is basically based on the HBM variant of the NPUs. And then 8100 would be the ones with the non-HBM. Right, so let me first cover the 8200. All of the platforms which I'm showing you here are based on single chip architecture. What that means is, basically, if you look at a Q100 based 8201 and 8202s, which is what we launched 2 years ago, these are both single chip platforms supporting 10.8 terabits capacity. 8201 is a 24 port, 412 port, 100 platform, so it's more 400 gig focused. And on the other hand, 8202 is more 100 gig focused. So it has 60 ports of 100 gig and 12 ports of 400 gig. And then just recently, a few months ago, we launched our Q200 based 1RU 32 by 400 gig platform. So all three of these platforms basically based on a single chip architecture. And one of the other things, basically one of the advantages this single chip architecture gives us is basically the whole architecture is very simplified now, right? I mean, unlike, look at our competition who are building a similar sort of type of architecture or similar type of capacity boxes with multiple chips. We are doing a single chip here, which means that the power footprint would be much lower, right? That there's no compatibility issues between the ASICs, and the software architecture is also very, very simple. One of the other key highlights which I want to touch upon here is the power efficiency of our fixed products here. So if you look at 8201 and 8202, these is 415 watts. What that means is for a 10.8 terabit box under 415 watts, which is just under 4 watts per 100 gig, right? This is a huge leap in terms of power efficiency compared to our competition, as well as even compared to ourselves in the past portfolio we had before. Right, 8202 is also based on a 10.8 T chip, but you see that the power consumption is a little higher there. And the reason for that being because we have a lot of rev timers because of the 100 gig ports, and that is why the power consumption is a little higher. Now, if you look at the Q200 base platform, the power efficiency goes a notch up here, right? And here we are actually talking about from 4 watts or just close to 4 watts per 100 gig. Now we are talking about 2.25 watts per 100 gig, which is again hugely in terms of power efficiency, which Cisco 8000 is providing here. In terms of suitability of roles for the Cisco 8200 products, these are, like Mauricio explained earlier, these are suitable for core, peering, data center interconnect, and going forward aggregation role, as well as the WAN edge roles. This is sort of all of these roles are covered by 8200, and that the reason for that being it provides relatively higher buffer and higher scale compared to our 8100 series. So now let me go on to the 8100 series and let's talk about that. So in the 8100 series, this is again, recall these are the platforms without the HBM, right? So here we have 3 different platforms. The first 2 are based on the Q202 and Q202L or Q201L ASICs, which is basically 32 by 100 and 64 by 100. And these are specifically targeted for some of our web scale customers who are users of dense 100 gigs, right? So 32 by 100 and 64 by 100. A lot of our customers are using these platforms to build spine and leaf or architectures with 32 by 100 being in a leaf role and 64 by 100 gig being in a spine role. And then recently, just with our 732 release, we have launched the 32 by 400 gig platform also in a non-HBM variant, right? So you just saw in the previous slide an HBM variant for this platform. This is a non-HBM variant. Again, similar architecture here, 32 by 400 and a single chip 12.8 terabits capacity. Now, let me move on and talk to you about a little bit looking forward, right? So all the products which on your left, I've just discussed with you, right? Now, let's focus on the platforms towards the right. Now, but before I go there, right, if you closely look at the SKUs, you'll notice that some of the SKUs have -O in them and some of the other SKUs do not have -O. What that means is that what -O means basically is that these are the platforms, the open platforms. Means that we are ready to take on a third-party software, such as Sonic, for example. Right. So basically, we provide a disaggregated form of hardware to our customers, and customers can integrate their own OS, and they can run their own OS with that. Right now, unlike some of the other sort of vendors for white boxes, we are not just providing off-the-shelf hardware here, right? We are actually want to stand behind what we are selling, so we actually integrate with the third-party OS which customers want to run. So there is an effort which happens before they actually go in production, where we actually doing a lot of certification and integration work with our customers to make sure that the software they are planning on running is actually going to be compatible and there are no issues they can foresee. And similarly, with that integration, we can also provide them the support on this if something were to go wrong in the future. Now let's focus on the roadmap here. So for the next 6 months or so, right? So in the next 6 months or so, We're going to have the 32 by 100, which is just about to ship either this month or next month. So we talked about that platform already. Now, the 32 by 400, so that platform, the third variant of that platform is going to come, and that's going to also support MACsec going forward. Now, the difference between the 32 by 400, the non-MACsec variant, which you saw, the one with the HBM and one without the HBM, the difference here is going to be that this is going to be a 2RU platform, not a 1RU. And the reason for that being because we have now additional PHYs to support the MACsec, we are going to have to change the design to 2RU because of the thermals and other factors which are going to actually impact this box. So that is why it's a 2RU platform rather than 1RU. So now let's move on and go a little bit zoom in into each of these platforms. So this is the platform, the 8201 and 8101 32 by 400, which we saw in the previous slides. So compact 1RU, 600 mm depth, so very compact form factor to fit in space-constrained environments, to fit in the 600 mm HC type of rack, so we have that compatibility there. Based on our custom requirements, we are also supporting either a port side intake and a port side exhaust on these products. And again, that's a very selective type of thing based on the customer requirements, because most of our customers are happy with the port side intake. There are some customers who want to use our products in a top of rack style networks, and that is where the port side exhaust is in. So we support port side exhaust on a need basis. Use cases, we have also talked about those. Both of these platforms support XR as well as the open software like Sonic and others. We also have a choice of power supplies here. So, depending on whether our customers want to use ZR and ZRP with our products, we provide a choice of power supplies. So let's say if the customer is not using ZRPs or not planning on using ZRPs, they can actually use a 1.4 kilowatt power supply with this box. And so just to keep the overall power consumption down. And similarly, if they plan on using ZRPs, then we provide a 2 kilowatt option to support that additional power requirements. Both of these platforms also support ZR on all the ports and ZRP only on the top row ports, right? So that's pretty much a norm. We have adopted that. The top row ports on this 400 gig platforms will be supporting ZRPs. And then one final point I want to make on this slide is, like Amar mentioned before, right? All of the products which we are seeing on the fixed form factors here, they're all, in fact, for all 8000 series, you're all QSFP based. What that means is that now you can use these ports, although it's a 400 gig ports, you can use them as a 100 gig natively or a 40 gig natively, or you can break them down into 4 by 100 gig or a 4 by 10/25 gig or 2 by 100. So you get all kinds of flexibility based on how you want to use it, right? Some of our customers, what they're doing is that although they're buying the 400 gig platform, they're not yet ready to go full-blown 400 gig with all the ports. So they're using some of the ports as a broken out into 100 gig or 10 gig, depending on their needs. And then some of the other ports they're using as 400 gig. And then these platforms also support Class C timing. So like Mauricio mentioned earlier, so aggregation is something which we are looking forward to in the calendar year 22. But from the hardware perspective, it's capable right now with the Class C timing support. So all of the platform which I'm going to show you have Class C timing support. Okay, so now let me quickly go on. So this is the platform. I'm not going to go into details again, but similar type of things, right? This is the one which is a 2RU, and it will also support MACsec. Again, this is based on a single chip Q200 with HBM. Okay, and this is going to come up in the April timeframe with our XR752 release. There's another product which we are working on, and this is for customers. So this is in line with what Amar showed you on a combo line card. So this is in line with that. So this is a combo box which provides 24 ports of 100 and 8 ports of 400. And the reason for specifically to get this box or work on this box is basically for customers, especially some of our European and Asia Pac region, they're still predominantly on 100 gigs. And from their point of view, they want to buy and they want to run this product in 100 gig, but they don't want to go with the 32 by 400, obviously because the licensing and all of that will be aligned to 400 gig in that case. So here, this platform provides a good option for those customers who are still predominantly on 100 gig and want some support for 400 gig. So this provides 24 ports 100 and 8 ports 400. suitable for roles, again, core, peering, SP, depending on the needs. Right? And again, this platform, although the support from the XR perspective will be in 733, which is coming up next month, the actual FCS target from the hardware perspective is April. And again, this platform also supports the Class C and breakout and ZRPs and all of those things. And then final slide here, from the product perspective, this is the two platforms which I showed you. These are both based on the non-HBM variants and designed for customers who are web scale, dense 100 gig, top of rack, leaf and spine kind of architectures, right? So the 64 by 100 gig is already shipping. The 32 by 100 gig will ship very soon. Okay, and I think that's pretty much it from the portfolio perspective. And finally, as I'm closing this, I just wanted to mention that if you look at the Cisco 8000 story, we started with our acquisition of Liba back in 2016, and our first product launch was 2019. And since then, if you follow our story, you will see that it's an industry leadership we have established, both from the modular footprint as well as the fixed footprint, with a single chip architecture, a common architecture, which we are following here. Continued innovation. So what you saw today is not all, right? Like Amar and Mauricio both mentioned, as we have just announced the P100. So going forward, you can look forward to have new products coming up from Cisco 8000 series, which are based on P100 and beyond. And similarly, from the interfaces perspective, it'll be 800 gig and beyond, right? So, and then from investment production perspective, like Amar mentioned, right? So we have whatever we are building with the backward compatibility in mind, right? So all of the fabric cards or new line cards, which Amar has showed you, they're all backward compatible with the previous generations, right? So if you look at where we were 2 years ago and where we are today, and where we are going as we go forward with P100 and beyond, you'll see an interesting story of evolution of this product line. So